In this lesson today, I'm going to show you guys what we can do with 2 layers and 2 planes PCB. Now first of all, I have a completed schematic here, okay, with a 555 timer on this side and some JK flip-flops, and I have my decoupling capacitors, one for each of the ICs. Right? I've also consistently named my 2 clock as clock and clock 2. Now, moving forward, this is what I would do. I will click on Tools. I will do a Translate to PCB. Okay, do a Next. Now, we usually use a default or a single side, but today we are going to use a 2-signal, 2-plane technology file. You can switch your dimension to mils, and we can change that later. Now, over here, instead of just keeping use layers from chosen technology file, we're going to click on Define Layers. We are not going to change this electrical layer part, but down here in layer 2 and layer 3, these are the inner power planes. We're going to tie one of the planes to our ground and the other plane to a VCC. So after we translate later, you can see that one plane is the ground plane and the other plane is the VCC plane. So moving forward, we just click Next, and we click Next. Okay, we just place the thing outside first because we want to do some manual placement. Click Next, right, and then we will finish off. Now, from here, before I start to place any components, I want to set my spacings and my track width. So I'm going to go to Settings and I'm going to click on Technology File. Let's set the track width first. Okay. In mils today, the lesson says that we have to set the signal to 20 and the power, let's set it to 30. Although in some case, you will not have power lines because the power lines have all gone onto the ground and VCC planes, but there are some cases you will still have some power lines running on the top and the bottom layer. Now, after we are done, we apply this one. Let's also continue to make sure that we click on Next to make sure ground is ground class, VCC has to be power class. The others are all signal class. You can show the unnamed ones, all signal class. And we go to class and make sure power is power type, ground class is power type. The rest are all signal type. So we just click OK. We go to spacings now. Right now, in mils, again, we have to set our spacings. Let's say, for example, the track to track, we are supposed to set spacings of 20 mils. So let's set track to track as 20 and the rest pad to pad as track to pad as well. Track to VR, we're gonna do that. The rest is okay. Okay, you might want to also set a VR to VR or with the same as 20. The rest we don't want to touch them. Let's leave them as default. And we click Apply. Okay, and we close. So from here we want to start placing our components, so I'm just going to move them everything into the box first before I start placing them. So a C4 is actually a decoupling capacitor, so I'm going to pull C4 up to protect U2. C3 is another one, it belongs to U3. So the rest of the component you can just place them randomly. Right now, after doing all the placement, we want to take a look at some other things. Now let's take a look at our components here, C4 and C3. These are decoupling capacitors. As you can see, there's no yellow linking from that's missing from here. What happened is that they are connected to the VCC and the ground. So if we go on to View, and let's show power plane. Let's choose the ground plane. You can see if you zoom in, this pin is actually connected to the ground plane, and this is also connected to the ground plane. This is also connected to the ground plane. if you can see the fan out, right? They're all connected to the ground plane. Now, so that's why there's no linkage there, because they are already connected to the plane. Now let's take a look at the VCC plane. Now you can see this pin is connected to the VCC plane, and you can see a few more connected to the VCC plane. So that's why the routing is not necessary for these components. Okay. The link is missing because they are already connected through the ground plane and the inner VCC plane, right? So right now what is left for us is the rest of the lines that we have to connect, right? So let's say you click on the line and you want to route. Now you have to take note at the bottom right, okay, it says top couple. Okay, you can switch the layer if you doesn't want to route on the top couple. Okay, you can always switch by doing right click and click on track layer, and then you can switch to the bottom or top. Try not to use the plane, ground plane and the VCC plane. So we're just going to use, for example, now we switch to the bottom. Now I'm at the bottom couple. Okay, so if I route another line, I'm still at the bottom copper. I can do the same thing and switch back to the top copper. Alternatively, I can just press L here and I will switch, and I'm now at the top copper. Okay, so I'm going to just finish up here, these things here. Now sometimes you might find that your routing is a bit difficult to route, too coarse, so you switch to the grid. Make sure the grid is 50 mils XY, and then you switch to half grid, apply. That will make your routing slightly easier. Now I'm going to show you guys how do we make use of what we call vias. Okay, and now let's say I am now at the bottom copper layer as I start routing, and I want to come to here, but I cannot route across because that will short circuit. So what happens when I'm halfway through? I'm going to change layer. So let's just do so by pressing a L, and then I'm going to change to top copper, right? And I'm going to connect here. As you can see, at the point where I change it, there's a via that appears. Okay, the via brings the bottom copper up to the top copper track, and that's why I can complete my routing. Okay. Now last but not least, I'm going to show you guys how do we route on power planes, which is something that we don't usually do. But in this case, if you take a look at, let's go back to our schematic, we have two clock lines, one here and the other one clock 2. Now these two clock lines could be potentially noisy, so we want to protect them against EMI and EMC interference. What we can do is we can route on the top and bottom line, and we have parallel ground lines that is shielding it. But to make our life easier, what we can also do is you just want to route on, let's say route it on the ground plane, and we shall see what happens. Let's say click L and ground, select ground plane, and then let's complete the routing on the ground plane. Now, if we go back to view power plane and show ground plane, now, as you can see, okay, these two lines are on the ground plane, but they are not shorted to the ground because there's a space gap here, right? They are shielded and covered with ground. The main area plane is actually grounded. Okay, so if they are routing here, their left and right neighbors, they are actually grounded.